Welcome! By the end of this video, you should be able to solve this problem, and this problem. And do consider solving them and leave your answer in the comment section and you'll get to know whether you are correct or wrong. Now let us consider this polynomial and we are expected to differentiate. Now let us start off by writing the y, the x. The y dx is a symbol for representing differentiation. And there is something I want you to remember each time you're differentiating. I want you to remember to times and remove. And what that simply means is to times the power by the coefficient. And then you remove one from the power. All right, let's start with this term. So 3 times 4 gives us 12. And then we remove 1 from 3, that gives us 2. Now, there's an invisible 1 here, so let's just write this for the moment. 2 times 1 gives us 2. And if we remove 2 from 1, we get 1. Okay, but this is almost the same thing, so there's no point writing this one here and also this one here. So let's go over to the next term. And there's an invisible 1 here also. All right, let's just write it for the moment. Now, 1 times 2 gives us 2. Okay, and if you remove 1 from this power here now, we'll be left with 0. And remember from the law of indices that any number raised to the power of 0 is equal to 1. So this simply means that this is equal to 1. All right, so let's go over to the next term. The next term is a constant. And what is a constant? Remember, we are differentiating with respect to x. So this means that we are considering x as we differentiate. Any term that does not involve x in this expression is a constant because we are differentiating with respect to x. Therefore, if any term here does not have x attached to it, it is a constant. This term here has x attached to it, it is not a constant. This term here has x, it is not a constant. This term here has x attached to it, it is not a constant. But this does not have x attached to it, therefore it is a constant. And in differentiation, when you differentiate a constant, it is equal to 0. So we have 0 here. So if we simplify this further, we'll have that 12x squared minus 2x plus, remember the whole of this is 1 according to the law of indices. Now if you multiply 2 by 1, we'll get 2. There's no point including 0, and this gives us the final answer. Now we shall be solving 6 more problems so you can get better understanding of differentiation. Now, let us start with this problem. Now, this is very similar to the one we just finished solving. So, the y dx is equal to 2 times 2 gives us 4. Remove 1 from 2, we'll be left with 1, minus, there's an invisible 1 here, remember. So, 1 times 3 gives us 3. So if we subtract 1 from 1, we are left with 0. And according to the law of indices, this is equal to 1. Now, this is a constant because it doesn't have x attached to it, since we are differentiating with respect to x. So this is 0. So if we simplify further, this gives us 4x minus 3 times 1, according to the law of indices, gives us 3. And that gives us the answer to this problem. And I need you to know that each time you're differentiating a term, for example, 3x, where the x is not raised to a power greater than 1. I mean, something like 2x, 3x, 4x. If you're differentiating with respect to x, it is still the same thing as getting rid of the x and then you're left with 2, with 3, and with 4. That's the reason why we differentiated 3x here to give us 3. So if we differentiated 4x, we would have had 4. If we differentiated 5x, we would have had 5. In as much as the x is not being raised to a power above 1. So here is another problem. But in a problem like this, the first thing we have to do is to expand the bracket. So we can have something like y is equal to 2x multiplied by 4x, we get 8x squared. 2x multiplied by minus 3, we get minus 6x. 1 times 4x, we get plus 4x. Then 1 times minus 3, we get minus 3. So let's simplify further. We get the y is equal to 8x squared minus 6x plus 4. We get minus 2x minus 3. Now we can now differentiate. So we get the y, the x is equal to 2 times 8 gives us 16. And if we remove 1 from this power here, we'll be left with 1 minus, there is an invisible 1 here, remember? So 1 times 2 here gives us 2. When we remove 1 from this, we get 0. And then this is a constant, and if we differentiate a constant, we get 0. And if we simplify further, we would get that 16x minus, this is 1, remember? So 2 times 1 gives us 2. And this is the final answer. Here is another problem, and one of the terms here is a fraction. So the first thing you have to do is to get rid of the dividing line and try to make this fraction very, very linear. This is what I mean. We get that y is equal to 5x squared minus 3 times 1 all over x. It is still the same thing, plus 6. So we get that y is equal to 5x squared minus 3x raised to the power of minus 1, because negative index, according to the law of indices, employs reciprocal. So 1 over x is the same thing as x raised to the power of minus 1 plus 6. Now we can differentiate. So we get the y, the x, is equal to 2 times 5 is 10. Okay, then we remove 1, we'll be left with 1. We remove 1 from 2, we'll be left with 1. So we get minus 1 times minus 3 is plus 3. So we get this plus 3x raised to the power of, remember, we have to remove 1 here. So minus 1 is minus 2. Minus 1 is equal to minus 2. So we get minus 2. And this is a constant because it doesn't have x attached to it. Therefore, it is equal to 0. So the y dx of this expression is equal to 10x plus 3x raised to the power of minus 2. Now here is another problem, and this problem is somehow similar to the one we just finished solving. The first step is to get rid of this dividing line and make this expression as linear as possible. So we can do that by doing this: x raised to the power of 5 all over x minus 3x raised to the power of 3 all over x. They are the same thing. Or you can also do it this way: x raised to the power of 5 minus 3x raised to the power of 3 bracket 1 all over x. It is still the same thing as this one here. So if we go for that to simplify, we'll get x raised to the power of 5 minus 3x raised to the power of 3 brackets x raised to the power of minus 1. Remember, negative index employs reciprocal according to the law of indices. So this is the same thing as this. So if you're going by this method, then you have to open the brackets, multiply this by this, and multiply this by this, and then you continue solving that way. But we wouldn't be going by this method. Let's go by this method. So having gotten to this point, we can just divide through. If we divide this by this, we'll be left with x raised to the power of 4. And if we divide this by this, x cubed divided by x will be left with 3x squared. Okay, one of the x's here would take care of this one, okay, and one of the x's here would take care of this one. Now we can differentiate, okay? So if we differentiate now, we would have that the y, the x is equal to, there's an invisible one here, so 1 times 4 gives us 4. X raised to the power of 4 minus 1 gives us 3. And then we go over to this one. 2 times 3 gives us minus 6. And if we remove 1 from here, we're left with 1. Okay, which is the same thing as 4x cubed minus 6x. Here is another problem. And once again, we need to simplify this further. Okay, so we have that y is equal to, remember that this is the same thing as saying 4 times 1 all over square root of x plus 5. Okay, and remember the square root of a number is the same thing as that number raised to the power of half. So we can say that y is equal to 4 times 1 over x raised to the power of half plus 5. So if we go further, we get that y is equal to 4 times, remember, negative index employs reciprocal, so we get that x is equal to minus 1 all over 2 plus 5. So with this now, we can differentiate. So we have that the y, the x, is equal to minus half times 4 gives us minus 2. Now we need to subtract 1 from this index or this power. So if we subtract 1 from minus 1 all over 2, we would get minus 3 all over 2. And remember, this is a constant. When we differentiate a constant, we get 0. Okay, the answer becomes minus 2x minus 3 all over 2. So with this, we've come to the end of the video, and you can always pause the video at any point if you didn't understand the solutions properly. And I hope to see you in the next video. Take care.